Hvězda.
Hello, my name is Angela, and the topic of my presentation is Agile. Agile, this is a family of flexible approaches to software development. And such approaches are also sometimes called frameworks or Agile methodology. And the key role in this concept is played by Manifesto. Agile Manifesto was created in February 2001 by 17 software developers in written form. Now you can see on the screen 4 main values, and I'll read them. Individuals and interactions, our comprehensive and tools, our processors and tools. Working software, our comprehensive documentation. Customer collaboration, our contract negotiation. Responding to change, our following a plan. How you can pay attention that I have selected left part in the sentences. Because the creators of the methodology came to the conclusion that the parts that are on the left are more priority. And besides the 4 goals in the methodology, there are 12 principles. I won't dwell in each point in details, but I say common messages. Agile is needed to show the result to the client in a short time. For this, a large project is divided into segments from 1 to 4 weeks. And these segments is called sprints. Each of sprints includes planning, testing, development, and demonstration. At the end of each segment, the client should receive a work product. It's very important not to take a lot of tasks at the same time. Since then the developer will rush, they switch between tasks, lose motivation, and how you can understand this is a losing strategy. The Agile methodology says that you don't need to try the complex and amazing product right away. While we improve it, we can be overtaken by small but fast competitors. And by the time we finish the whole cycle of works, your project may no longer be needed, but a lot of time, money, and efforts will be spent. Therefore, Agile allows you to quickly start your project, overtaking competitors. Next point, developers and business people must work together throughout the entire project. Face-to-face communication is the best way to transfer information to and from the team. And thanks to regular communication with businessmen, the team feels the importance of the work. Okay. It should be noted that agile is a general direction, and the frequently occurring words like Kanban and Scrum, its varieties. Now you see the main agile methodologies, and it's Scrum, Kanban, extreme programming, future driver development, agile unified processes. And on the example of Scrum, I'll tell you which roles in the team. At the rolling scope, we had a task with Canvas, and at first I thought draw this picture with use my own project, but my picture looked awful, and I understand that I'm a bad artist, and I can't draw even normal circle, because I use paint. Scrum roles. First person is customer, a person who has an idea and money. I specifically wrote this phrase for the customer, as there is a funny video about this situation, and you can see it on the internet. The video is called The Expert. Next person, product owner, is one person responsible for product backlog and for prioritizing the product future in each sprint. This person without technical knowledge, but he has a common vision, and he knows what the product is for, and problems with release. I said earlier the phrase product backlog is an ordered list of everything what to be needed in the product. The Scrum Master does whatever is in their power to help the team, product owner, and organization be successful. He or she educates, coaches, and guides all team in use of Scrum. And the last is team. Self-organizing team that includes everyone involved with the design, development, testing, and delivery of the finished product. A curious note is that the team cannot be too big. For this reason, there is an excellent phrase. Every team should be small enough that it can be fed with 2 pizzas. In conclusion, agile don't mean fast. It means responding to change. You are responding to continued customer and stakeholder feedbacks. As you continue to learn and improve, and agile is very effective at work. Thank you for your time and attention. I think it's very good when team is small, because you know every person, you know what person do in your project, and you can communicate easy. Big team. Repeat, please. when a team is big, this team is not like a good collective, because I don't know. I think that it's very good when team is small. About when big, I don't know what say. Agile Manifest was created in 2001. I remember that the software engineer meet in mountains, and they discuss about work. No, I can't say no. Because I have never worked with Agile, and because many students took React topic, and it's something unusual.
Hi everyone, my name is Anastasia Sukhaverkhaya. I'm gonna tell about Docker, what it is and which problem it solves. When developing software, it can be hard to ensure that environment and dependencies on the developer's machine will be the same as those on the remote server, and to keep an application isolated thanks to the packages, libraries, and other stuff it will be needed to run it. So problem is to keep an application isolated. There is two ways to solve this problem. First one is virtual machine. Sorry, I'm very nervous. Yes, I try. But no guarantee. Okay. So, solution to this problem has been virtual machines, which keep application on the same hardware entirely separate and reduce conflicts among software and components and computation for hardware resources entirely to a minimum. The other solution might be containers. Containers uses a background process, a daemon, that is able to simulate the operating system on the container using only the kernel of host operating system. This significantly reduces startup time, CPU memory requirements, and computational speed. At first glance, when you're familiar with virtual machine, both are filling the same rule, and that's correct. However, containers have a key advantage which make it a better choice in almost all situations. Containers decouple applications from operating system, which means that users can have operating system clean and minimal and run everything else in one or more isolated container. And because operating system is abstracted away from containers, you can move a container across any server that supports the container runtime environment. Containers allow a developer to package up an application with all of the parts it needs, such as libraries and dependencies, and ship it all out as one package. And they provide a highly efficient and highly granular mechanism for combining software components into the kinds of application and service stack needed in a modern enterprise. Docker is a software, is an open source project which make it easier creating containers and container-based applications. It allows create, deploy, and run applications by using containers much easier. Originally built for Linux, Docker now run on Windows and Mac OS as well. Let's look at key advantages which will be provided by using. Dockers enable isolating and throttling, portability, composability, orchestration, and scaling. Docker's container enable isolation and throttling. Docker container keep application isolated not only from each other, but from the underlying system. Not only makes for clean software stack, but make it easier to dedicate how a given containerized application uses system resources like CPU, GPU, memory, networking, and so on. And also makes it easier to ensure that data and code will keep separate. Docker container enable portability. A Docker container run on any machine that supports the container's runtime environment. Applications don't have to be tied to host operating system, so both the application and the environment on the underlying operating environment can be kept clean and minimal. Container-based applications can be moved from one machine, from developer's laptop to a server, as long as the target system supports Docker and any of third-party tools that might be in use with it. Docker containers enable composability. Most business applications consist of several separate components organized into a stack. A web server, a database, an in-memory cache. Containers make it possible to compose these pieces into a functional unit with easy changeable parts. Each piece is provided by a different container and can be maintained, updated, swapped out, and modified independently on the order. Containers enable orchestration and scaling. This is most advanced behavior, which means that many containers containers will be used for scaling application across clusters of system and to ramp services up or down, to make spikes or in daemon, and to converse resources. Let's take a look on the fundamental concepts which will be used in Dockers. First one is Docker file. Docker file, each container starts with a Docker file. Docker file is a text file written in an easy to understand syntax that includes the instruction to build a Docker image. Docker file specifies the operating system that will underlie the container along with the languages, environmental variables, and file locations, network ports, and other components it needs. Docker image, once you have your Docker file written, you invoke the Docker build utility to create an image based on Docker file. Whereas the Docker file is a set of instructions that tell build how to make the image. A Docker image is a portable file containing the specification for which software components the container will run and how. Because a Docker file will probably include instructions about grabbing some software packages from online repositories, you should take care about to explicitly specify the proper versions, or else your Docker file might produce inconsistent image depending on when it is invoked. But once an image is created, it's static. Every Docker image is built from layers. Each layer except the last one are read-only. Each layer is only contains only differences between two images. Docker run. Docker run utility is the command that actually launches a container. Each container is an instance of an image. Containers are designed to be transient and temporary, but they can be stopped and restarted, which launches the container into the same state as when it was stopped. Multiple container instances of the same image can be run as long as each container has an unique name. And now I need to present which companies are using Docker. This is company like PayPal, Visa, and other. Actually, there are a lot of companies which use it, and almost 50 or more than 50% of them are orchestrated. That's all what I want to say. Okay, I have started English before 8 years, but I wasn't learning English in school. This is only my self-education. Sure, yes. Sometimes I have English courses, or I watch TV series. Sometimes it's binge watching. I can speak German. In Germany, I don't know. Actually, I was living a year in Germany, and but I wouldn't say I would stay living there. But maybe. There is no reason why I wouldn't not live. I think I can live anywhere. I can feel good wherever I am.
Hello, everyone. My name is Anastasia, and today I would like to talk a little bit about modern CSS layout methods such as Flexbox and CSS Grid. Currently, technology allows us to browse the web on many different screens, and the content must adapt to any device we use. Historically, there were several approaches to describe web pages. Previously, we used floats, tables, position, inline block, but all of these methods do not fully cope with the needs of modern web, for example, vertical centering. And that is why in my speech today I will try to answer some questions. What is Flexbox and what is Grid? What is the difference between them? Does Grid replace Flexbox? And when we should use both of them? Grid and Flexbox, they are both the most popular CSS layout methods. They not only allows us to create layouts that previously we could not create without using JavaScript, but also make it easy to understand and support the code. The flexible box module was designed as a one-dimensional layout model and as a method that could offer space distribution between items in a different an interface and powerful alignment capabilities. The main idea behind the Flex layout is to give the container the ability to alter its items, widths and heights in order to best fill the available space, mostly to accommodate to all kinds of display devices and screen sizes. To make the element flexible is easy. We should only set property flex or inline flex. In this slide, there are a few terms related to the flex layout model for the parent block. The following slide shows the properties for the child elements. Grid layout gives us a method of creating grid structures that are described in CSS, not in HTML. And it helps us to create layouts that can be redefined with media queries and adapt to different contexts. Grid is a CSS method designed for the two-dimensional layout of items on a web page. It has such terms like grid container, grid item, grid line, track, cell, area, and gap. The following slide shows the properties for CSS grid layout. At first glance, there are a lot of similarities between them, but because they are both web layout technologies, they are much more powerful than any layout technique that came before them, and they can stretch and shrink, they can center, reorder, and align things. However, despite some superficial similarities, they are actually used for very different tasks. They are each solve a very different set of problems. Let's focus on the differences. The main difference is that Flexbox is created for laying out items in a single dimension, in a row or column. And grid is for layout of items in two-dimensional rows and columns. Another important difference between them is that Flexbox works on content, while the grid is based on layout. CSS grids helps us to create the outer layout of the web page. We can build complex as well responsive design with this. That is why it's called layout first. Flexbox mostly helps align content and move blocks. That is why it's called content first. Grid is mostly defined on the parent element. In Flexbox, most of the layout beyond the very basics happen on the children. Also, grid is better at overlapping. Grid is requiring less media query intervention with really powerful functionality like auto layout, min max, repeat, and autofill. And the last difference is that grid is much newer than Flexbox and has a bit less browser support. Flexbox has 99% support and grid 97.5% support. After comparing the two methods, we can ask, does CSS grid replace Flexbox? And the answer is maybe no, because grid can do things Flexbox can do, and Flexbox can do things grid can do. And why we should use them? Flexbox layout is most appropriate to the components of an application and small-scale layouts. And the grid layout is intended for larger-scale layout with which are not linear in their design. But there are a lot of situations in which we could use either one to do what we need, and a lot of situations where one is more well suited than the other. And of course, we can use them together. A grid item can be a Flexbox container, and a Flexbox item can be a grid container. And the next slide shows one more example when we can combine these methods. That's all. Thank you for your attention. Okay. Mm-hmm. Maybe if we have only 3 HTML elements, we can do 2 groups. The first will be home and switch, and the second will be logout. And we can set property justify content I say I forgot. Today, I know that today my colleague, I don't know who, are going to tell us about. Oh no, he will talk about grid. Yeah. How to center? If we need to center vertical, we can set property aligns self, and when we need to center horizontal center, we can use justify content center. Maybe one more question? No? Okay. Can you repeat? Yeah, I told about this, and I show some slides about this. Maybe.
Hi everyone, my name is Olga, and today I'm gonna tell you about React.js. So React.js is a JavaScript library for building UI interfaces. But do you know who developed React? Which company? Of course, Facebook, yes. Facebook did. The first release was in 2013, and 6 years passed, but React is still doing pretty well. It's one of the most popular projects on GitHub with almost of 140,000 stars now. So for us, as for developers, it's very important to know the situation on job market. So here is some statistics. Here is the number of open positions for different JS skills according to LinkedIn. Blue is for React, green one is for Vue.js, and the red one is for Angular, and you see that React is on top. So here is another statistics, the number of downloads from NPM for past 3 months. So you also see that React is on top here. So you know what to learn. Now let's see who used React. No, not who used, but another thing. So, but in fact, we can't compare React with Angular because Angular is a full-fledged MVC framework, while React is only the V for MVC. Okay, finally, let's see who uses React. So obviously Facebook does, then Facebook's own products like Instagram and WhatsApp, then Netflix, Code Academy, Airbnb, and others. Let's move forward and speak about components. So React is all about components, their composition and reuse. So component is independent and reusable piece of code which we could embed and reuse where needed. So let's see an example. Here is our famous task, fancy weather, and let's try to split this UI into components, because in React we split our UI into components, maybe into a lot of components. So how many components do you see on the screen? Maybe one or more. So how many? Okay. I suppose that there are a lot of components, and everybody of us could split it in different way, but we need to think about those components which we could reuse. So here is my answer. So the component of day weather we could reuse 3 times. Okay, let's move forward and try to write our first component. But before we start, let's speak about Babel. So what is Babel? Who could tell me what is Babel? Transpiler. Okay, it's transpiler or compiler. So Babel is a JavaScript compiler. Or transpiler. Okay, you know that there are a lot of browsers, and sometimes they do not support the newest features of JavaScript. So here comes to see Babel. So it simply compiles our new generation JavaScript. For example, some features of ES6, ES7, and ES8 into browser-compatible JavaScript, and all our problems will disappear. Okay, let's move forward and speak about JS6. It's a JavaScript XML. It's simply a syntax extension for JavaScript, which is used by React. So it increases readability of our code, and now we'll see an example. So in React we create elements. So let's see how to create a React element. So we just simply call React create element and pass the type of the element, then props and children. Okay. So here is how it will look without JS6. It's simple JavaScript. So let's see another example. So here on the left you see the example written using JS6, and on the right simple JavaScript. So what does Babel? It simply transpile our JS6 into React create element. So it's simply so JS6 is simply a syntactic sugar for JavaScript create element. As for you, which code is more understandable, on the left or on the right? On the left, yes, sure, on the left. So why we could use JS6, but it's not required using JS6. You could also write the code on the right. Okay, let's move forward. So here is React element. It's simple React element which is written using JS6, and we also could use JavaScript expressions inside our JS6. So okay, let's render our element into the DOM. So we need to choose an entry point for our application. So where we the entry point of our applications. So let it be div with ID root. Let's suppose that we have somewhere in our application an HTML file, and in this HTML file we have a div with ID root. So to render our React element, we just call React DOM render, we pass as a first parameter what we want to render, our React element, and as a second parameter where we want to render it, so it's a root. So, and then we'll see on the page, hello, running scopes. Here is the output. Okay, let's move forward. What is component? Component is simply a function which receives props and return React element. So here is a dump component. It doesn't receive anything and it returns React element. So here is another component. As I said, it receives props and return React element. So the props are read-only. You should remember it. So here is another component written using arrow function. And here is another component which is written using ES6 classes. So there is a difference between these two components. The first one is stateless component. It means that it doesn't have a state. And when we write a component using ES6 classes, it will have a state. So we will see it later. So let's render our component. React element can represent a DOM tag or our component. You'll see it. Okay, let's finally render it. So it's how we could render a component. It's pretty simple. We call React DOM render and pass as a first parameter our React element, and as a second parameter where we want to render it. So in root, in div with root ID. Okay, as I said before, there are stateless components and stateful components. So let's have a look at stateful components. So sometimes we need our components to store a state and sometimes to perhaps change it. So we use stateful components which have simply a state. So on click, the state of this component will be changed. Okay. Here is a number, a really huge number, and it's connected to React. So I want you try to guess what does this number mean. So what it could be about what we were speaking before. What? What? Okay. So so it's connected it's connected with components and with one famous company. Try to guess which company? Facebook, yes. Okay, here is the number of components in Facebook. So, okay, it's just a curious fact, I suppose. Okay, let's move forward. Sometimes we need, we will speak about lifecycle methods, and sometimes in our components we need to free some resources. So there are methods component will unmount. So when a component will be deleted from the DOM, so this method will be called. And there is component did mount, where also we could do something what we need to do. Okay, let's move forward. In React, we can handle events. In this example, we have event onClick, where to which we pass a handler, handle click, and in our constructor, we need to bind this handle click in order to have this in our handler method. So perhaps, for example, perhaps now it's a little bit weird, but okay. Let's see how it works. It was our previous example. It's okay. Okay, so on the bottom we have button which has an event on click. So we pass the open model handler, which on click will change the state of our component. Okay, here is a composition of components. We just embed components day weather into weather app component, and we reuse day weather 3 times. So let's see an output. So it will be like this one. Okay, and at the end, I would like to speak about virtual DOM. Perhaps you know that React uses virtual DOM. So because operations with real DOM could lead to some problems with performance. So React uses virtual DOM. So what it does, so it stores an every time a tree of our application, so which you see on the top. And if we change state, it rebuilds this tree. And after rebuilding this tree, it compares the previous state of our application and the next state of our application, and it will apply change to the real DOM only of what is changed, and do not re-render the whole DOM. So here is why React is powerful. So that's all. Thank you for your attention. Do you have any questions? Yes, I've tried it. The examples provided in my presentations, were mine. So. Okay, because it's, I suppose it's in France now, and it's quite easy to learn. It's, I suppose, easy to use, and it's fast, I suppose, because of real DOM. So yes, that's why, yes. Yes, I have some programming experience. Okay, yes, I'm graduate from Belarusian State University of Faculty of Applied Mathematics and Computer Science, and I've been working for 3 years as a programmer, but not in this area, let's say so, not in front end. Java, yes. So, but I don't like to answer any questions about Java now for a moment. Okay. What? I know they are completely different ones. Now, I think that it's more difficult. Yes, more difficult to learn. It's pretty. It's changed pretty fast. So you should always be up to date. So and yes, let's say so. Okay, thank you.
Hello, let me introduce myself. My name is Julia. I want to tell about SVG. SVG is a vector graphic format based on XML and is used to display a variety of graphics on the web. Under the hood, SVG documents are simple text files that describe lines, curves, shapes, colors, and text. A perfect example of using SVG is the Euronews site. Here each icon and even the name of the site were created with SVG. Later I will tell you in what cases and why it's convenient to use this image format, and now explore some of internal components SVG. Coordinate system. The coordinate system of SVG is a bit different from the coordinate system of mathematics. In a normal Cartesian coordinate system, the points x and y equal 0 at the lower left corner of the graph. If x increases, the points move to right in the coordinate system. If y increases, the points move up. In the SVG coordinate system, the points x and y equal 0 at the upper left corner. If the y-axis does reversed in compression with a normal coordinate system. If y increases, the points move down, not up. Basic shapes. SVG has some predefined basic shapes that can be used by developers. Circle, ellipse, rectangle, line, polyline, polygon, and path. You can immediately understand what element what forms each element draws based on its name. Each element, besides the path, it draws any shape that we can see on the slide. How we can add SVG to our page? There are 4 basic methods. Tag image, CSS property background image, tags SVG, and object. Image or background image, these 2 methods are very similar. In both cases, you need to write the path to the file. Here, no possible to work with graphics, so such method are best suited for content images that don't need interaction. For example, icons, diagrams. Object. An object tag, you also need to write the path to the file. You can manipulate an object using CSS. Scripts, animation work if they are described inside SVG. This method is suitable when you need to insert some kind of interactive elements, toys, graphics, and various complex objects. And of course, SVG tag itself. In this method, you already need to write the code of the image. We can use all features of SVG, change size, color, animate, because we have access to all its attributes. Most often, this method is used for buttons, icons, small animations, in which you can easily change the different properties of SVG. If the animation is harder, it's better use object tag, because a large SVG file is bad readable. Animation. There are 3 ways to add animation to our page. SVG can be animated by adding an ID attribute or class to SVG tag and then styling them in CSS using keyframes. Animate is an animation tag built into SVG itself. It defines how the attributes change from start to end values during specified animation. Because SVG is a document which consists of tags, we can use JavaScript for animating and interacting. For animating and interacting with SVG. CSS is used for simpler animation, tag animate. I not recommend use because this method is likely to move. To be removed from browsers in the future. What about JS? This method offers more features. Advantages, why we should use SVG. Let's analyze the benefits. Vector images are resolution independent and can enlarge any part of the SVG image without loss of qualities. Browsers just recalculate the mass to the image that to avoid resolutions. On the slide you can see two pictures and the difference in format between format is not visible. But if you enlarge pictures, the difference is obvious. Interactivity and programmability. Interactivity, virtually any kind of animation can be added via styling and scripting. As regards programmability, change SVG easily. You can use any text editor. You can also use popular vector graphic format or vector graphic editing software such as Adobe Illustrator, CorelDRAW, and Sketch. On the slide, you can see the SVG file is opened in Sketch, and to the right, the same file is opened in a text editor. As SVG files are scalable, they can be saved at a minimal file size. Moreover, you can make your SVG file smaller using a special utility gzip. SVG images are defined in XML text files, so keywords and descriptions can be used and more easily recognized by search engines. Also, a plus is that SVG is officially supported by all major web browsers, including Internet Explorer 9 and later versions. In spite of all the positive aspects, there are some disadvantages to using SVG. No support for other browsers. For example, Internet Explorer 8 and below versions. File size is growing rapidly. If the SVG objects consists of a large number of small parts. No support for three-dimensional graphics, so the photo in SVG don't work. In conclusion, I want to say that despite all the negative points of using this format, its advantages still exceed. SVG elements are easy to manage. Will make your website a lot faster, and you won't need to update them every time when a new resolution display comes onto the market. Thanks for watching. Sorry, repeat. SVG file consists sorry. Any image. I, for example, can use attribute alt. Thank you. If I understand you're right, SVG file sorry, I don't understand. I told him my presentation. Yes. Now I'm nurse, and earlier I told my presentation better. Sorry. I choose myself this topic. When I did the task wheel, I had to use this image format, and I wanted to know more about it, and I haven't time. And when I saw this topic on lists, I'm happy. Thank you.
Okay. What's up, guys? Let's introduce. I'm Zhenya, and today I'm going to tell you about React basics. So the first question is, what is React? React is a JavaScript library that is used for user interface development. So there is a lot of information I would like to share with you, but in this case I would like to introduce you with props and state and a little bit of JS6. Everything in React is a component. Usually it's JavaScript classes. And when you create a React component, you create a child class from the React component. In this case, we create a basic React component. So we have to give name of our class, it's hello, and it has to extend React.component. This is a rule and you just should remember it. Also, in your component, you can create some methods. In this case, we've created a render method, and here we would like to see. Here we see h1 tag, and it shows us what we're going to see on our display. To render our application, we should use react.tom.render. So here we can see our hello component and our entry point of application. This is document get element by ID root. HTML syntax, as I've mentioned, is JS6. JS6 allows us not moving JavaScript inside HTML, but it allows us to move HTML to our JavaScript code. So there are two data types in React. It's props and state, and it can be maybe a little bit complicated at first sight, but actually it's not really hard, and there is a really big difference between them. The main difference is that the state is private and can be changed from its component. Props are external and not being controlled by a component. So let's talk a little bit about props. Generally, our hello component is static, and it renders the same message. The significant part when you work with React is it's reusable, which means an ability to write a component which can be used in some other cases. For instance, to show various messages. So here we added message my friend inside our hello component. To achieve reuse, we're gonna add props. This is how we transfer props to components. We named the props message and gave them my friend value. We can also get access to props inside hello, referring to this props message like this. This is an example. Okay. The sequence's result is hello my friend, the same like it was before, but we used props. The reason we wrote this props message inside operator brackets is because we want to say JS6 that we would like to use a JavaScript expression. It's called shielding. So now we have a reusable component that can render any messages that we want. But what if we want a component that can change its data? We will use the state instead. So let's talk about state. Another way to keep data in React is the component state, i.e. its inside state. Unlike props that can be changed directly by component, the state can't do this. So if you want to change data in your application, for example, based on user interaction, it has to be in the component state inside the application. So to initialize state, just set this.state in your constructor class method. Our state is in fact an object which is in our way has only one key with message name. So here's an example. We've added a constructor and our state with message my friend from state. Before setting the state, we need to call super inside the constructor as on previous slide. That is because this factor is not initialized before calling super. Change state. To change state, just we should call this .setState, passing the new state to an object like argument. We do this inside the method and we will name it update message. So here in this example we added this method in our application. Also we have to pay attention because we have to connect the key this with the update message method to our application work. Otherwise we can't get access to this method. The next step will be button creation for a click, so we can initiate the update message method. So let's add a button to our application. So here in this case we've added a button with some actions I'm gonna describe you right now. Here we catch an action by an event on button through onClick. As soon as it's ready, we will call the update message method. There is the wall, our component. So with our constructor, update message method and render method, which renders everything that will appear on a display. Update message method calls this.setState, which changes this.state message value. And when we click on the button, we have the next message, hello my friend, from the change state. So the conclusion is we have to know what is props, what is state. We should understand the difference between them. Also must have is to know what is JAVASCRIPT, why we should use it or we shouldn't. And I think this is all for today. Thanks. Which of them? Okay. Yeah. So actually, we use super to initialize. Okay, we have something in in parent class, and if we want to that class extends something, we should use super. So everything that parent class has will be given by this new component with calling super, I think. Actually not. This is a new technology for me and I'm gonna use it, I think, as soon as it's possible, and that's why I chose this topic, to learn something about new technology that I would like to use in the future in my life. That was my choice, yeah. Why I'm not interested in another? As a matter of fact, React is the most popular framework, and sorry? I guess, yeah. This is a library because it's some JavaScript code with a lot of functionality, and this is library. Actually, I'm not really good in React, and I can't answer that question. Okay. This is a new technology, sorry. Okay. Yeah. Yeah. Again. So there are two data types. So if you wanna again. Who knows? Thanks. Yeah.
Testing.
Hello guys, my name is Nastya and I'm going to tell you about Scrum. To begin with, let's refresh our knowledge about what Agile is and its core values. Agile says that people and interaction are more important than processes and tools. A working product is more important than exhaustive documentation. Cooperation with the client is more important than agreeing with the terms of contract, and ready for change is more important than following the original plan. So now let's talk about Scrum. What is Scrum? Scrum is a framework that helps us to solve some problems that change in the process and to deliver our product with the best possible value to customer. The main task of Scrum is to bring the opportunity to change and implement new ideas into the process. And the main feature of Scrum is the involvement of all participants into the work, and each participant has a specific role. There are different types of Scrum: social Scrum, pragmatic Scrum, and pure Scrum, but they are all united by three main things. It's roles, artifacts, and events. I suggest that we can look at this things in more details and in general to process of Scrum by some funny example. Let's imagine a modern man that lives in a metropolis and works hard and really wants to relax in nature. And it takes a long time to get to the nearest forest, and this man has no time for long trips. So he decides to order a small forest in our company. And after long meetings and proposals that our customer didn't approve, our company decides to turn to Scrum. After all, Scrum will allow you to quickly and soundly create a product. The main thing of Scrum is our Scrum team, and so let's create a team. The first character is a product owner. He will be the link between customer and our development team. His main task is to maximize the value of the product being developed and the team's work. And his main tool is a product backlog. Product backlog consists of necessary work tasks that's sorted in order of priority. Next character is a Scrum Master. He will work directly with the development team. He will organize meetings, monitor the efficiency of the process, and remove obstacles in the work. And finally, our development team. It's worth noting that it should consist of 5-7 people. There will be less talk and more work. And of course, we should create our Scrum team according to the Scrum guide that tells us that this team should have following qualities and characteristics. First, to be self-organizing. It means that no one, including a product owner or Scrum Master, can tell our team how to convert product backlog into our working product. Next, be multifunctional. It means that our team should have necessary skills to produce a working product. And it should follow the Musketeers principles. It means that the whole team is responsible for the work performed, not individual members. So we create our dream team and we can down to work. We have we already have some requirements, customers' requirements, and we can implement them into our product backlog. Also, we should divide the time to work on all project into small parts, which named like sprints. They can last from 1 to 4 weeks. And before the start of first sprint, we should gather all whole team for sprint planning meeting. At this meeting, we set ourselves a sprint backlog. It's a goal for current sprint, assign everything to the tasks, evaluate them, and priority them. And let the sprint begin. Every day we will have daily meetings. They will last for a maximum 15 minutes, and each member of our team will have time to answer 3 questions. What did I do yesterday, what I'm going to do today, and what are the problems? During the sprint, we will actively using the Scrum board. At this Scrum board, we locate our tasks in 3 columns: to do, in progress, and done. And at the end of sprint, we have a working product that our customer can already use. Also, we gather our team for sprint review and sprint retrospective. To evaluate the efficiency performance in the previous sprint, predict the expected performance in the next sprint, and identify some problems, and etc. It's worth noting that also we can make changes to the project during the development, but these changes should be directly related to the current product. For example, if our customer asks us to build a mansion in the forest, we will have to refuse it because the Scrum is not multitasking. So we will improve our product until our customer says, yes, it's what I really want. That's it about process. Now let's talk about advantages and disadvantages. Scrum has attractive advantages such as Scrum is customer-oriented and adaptable. It means that Scrum gives our customers the opportunity to make changes in their requirements at any time, but it doesn't guarantee that these changes will be made. Scrum easy to learn and save time by eliminating non-critical events. Scrum allows you to get a working product at the end of each sprint. And Scrum focused on a self-organizing multifunctional team capable of solving the necessary task with the minimal coordination. Of course, Scrum has disadvantages. Due to its simplicity and minimalism, Scrum sets a small number of rather strict rules. However, this conflicts with the idea of client-oriented approach in principles, as the client doesn't care about the internal rules of the development team, especially if they limit the client. And next week feature of Scrum is that it's very difficult to create a self-organizing multifunctional team. It's lower cost of them coordination, but it's higher cost for motivate and train them. So that's it. Thank you for your attention. At our sprint planning meetings, we have some tasks which our product owner bring from our customer. And product owner have like a manager which interested in customer tasks. It's see how we should made this product, and according to these things we choose some tasks and do it in our sprints. I guess we allocate our task in the third column when we do all things that we should do in this sprint, and it's finally. Okay. Which? What are the problems? I guess that's at this daily meeting. He can discuss it with Scrum Master, and maybe in the time of this meeting and after it, I think.
Good evening, my name is Elena, and I would like to talk a little bit about React, favorite one, and special its addition with hooks. So in the last release, February 1, 16.8, hooks were shown in stable release. There are so many, I would say, positive reactions to them, and even some discussions regarding if the hooks and new React with hooks is the end of Redux. That is necessary to have a look at them and decide are they so cute as they described. So first of all, it is necessary to mention that React with hooks perfectly works with existing code. And as we know already from the previous speakers, components in React are created with the classes. Hooks allow us to create components with functions. And that doesn't mean that we cannot work with classes anymore. We can work with hooks, we cannot work with hooks. It's only upon our choice. And React do not plan to delete classes from application or from the future creatings. What else necessary to mention? That hooks doesn't mean that you will need to use some other logic or to change your understanding about React concepts. It also offers even better way to work with that. Why there was need to create something additional to existing library? React is pretty nice, but it has a list of disturbing problems and make developers think if they need React at all. And let's have a look on them and maybe try to find how hooks can solve these problems. The first one is a wrapper hell. If you have a look on any application, existing application of React, you will find something like this. And because it happens because React itself doesn't give way to attach reusable behavior to a component. So somehow you need to put your component in the layers of higher order components of some abstractions and so on to give it a way to reuse the behavior. And with the React hooks, you can extract the needed logic and to use it in different components, and even share it not only in your application, but in different applications, I think, and with your team. The second problem is working with complex components. When your application starts to grow and when your components start growing, it becomes hard to work with to maintain them, to manage them, and to work with the lifecycle methods. You need somehow to split your component. That is really difficult to do in classes. And to apply these lifecycle methods, you need sometimes to split connected code and to connect not related code. And it becomes confusing and even may cause extra bugs in your code. And with hooks, you can split your component in smaller functions, just based on the piece which is needed. And the last but not least important problem is work with classes at all. You can be familiar with how classes work in JavaScript, but you will be confused by some of its... okay, let me restart with this part. So working with classes is confusing, and working with this property, for example, in JavaScript is more hard for developers than in other languages because its behavior is different. And it's hard to remember that you always have to bind handlers, that you always have to understand props, state, and other methods which happens here in the class. Why not just to put your component in the function and work easily? And it really looks prettier. But what is the hook? Hook is the function which let you to hook to keep to keep the state or to keep some feature to your component and to work with it. The existing hooks in React are divided in two parts: the basic ones and additional. Basic ones may be expected as the most common in use. To my point of view and searching in Google, I think that useState and useEffect are more popular, and useContext is a bit less, but it placed in basic group by the React developers. I have no right to remove it from there. useState hook, it works with state. We call the useState hook inside a function component and add some state to it. So when we call in the useState hook, we get the initial state and we get the function which updates the state. We call all the hooks, and even when we create them, we call them from the React itself. And there is, especially for useState one, there is a special area, a little bit like a store. And there the updated state is kept. It has like memory cells in which it saves our changes of state. And when we need it, we just call it from there. The second one is a useEffect hook. When we would like to tell our application that our component needs to do something after render, we just put this hook and tell what to do. Important thing that we place the useEffect hook inside the function, and it helps to the hook to follow where it should work. We don't need to apply any additional APIs, for example, because it already knows where to work. And one more advantage of this hook that calling useEffect doesn't block your browser for a period of rendering. So it updates the screen and user doesn't mention anything. The last one placed in base hooks is useContext. It just lets us to subscribe to context and to search it, to get it and to subscribe to its changes. It doesn't allow us, for example, to change context from the hook. The thing what I forgot to mention in the useState hook was that usually in class created components we save state as an object. Here with the useState hook we can save state as a number or as a string, and it will be changed to an object by React itself. We don't have to think about this. And additional hooks are listed here, and they may be used I don't know, when you would like. Use reducer, for example, it looks similar as a use state one, but it returns the current state and dispatch method. Use callback works, it returns the memoized callback, and it changed only, it returns the callback and array of dependencies, and it changed only if any of dependencies changed. Now, use layout effect is similar to use state, for example, but it fires only after DOM mutations. No, to hook or not to hook is upon your choice. To my point of view, as having no experience with React, it looks more convenient to use. It looks more structured and easy to control everything what's happening. And that's all. Thank you for your attention. You can create your own hooks, and they also will be stored in React, I don't know how to better say, in React base, from which you will take the hook when it is needed. Unfortunately, I don't know. So the main definition, hooks do not work in classes. Yeah, because this is a different way to create a component. Thank you for your compliment. I was studying English from kindergarten, from childhood, and I graduated from Belarusian State University. International relations. I was working with a few projects at my current work, and also there was a huge project implementation of SAP in the concern, because I work in an international concern, but it paused for Belarus and Russian region till 21st. So there is no need now for my role in that team. I even got invitation. I was thinking about this way a lot, and I even tried. I finished, I graduated from some courses of business analysis, but it's different. It's absolutely similar to my work now, and it doesn't give any passion or inspiration. And when you're creating something with code, it's difficult, or it's similar to artwork. When you paint in a picture, and you get exciting during the process, and you get crazy after you got the final product. So something happening here. You may have lots of sleepless nights and just happy.
Hello everyone, I will tell you about Redux, but rather about state management library Redux and how does it manage its state of our application. We will talk a bit about React and its collaboration with Redux. Let's analyze three main concepts of Redux. Store, which coordinates our updates. Reducer function, which updates the global state in response to actions. Actions, functions that catch our changes and send the object of changes to our store. There is an approach in which the state is stored in one main component and all other components transmit and update their state throughout the chain. The advantage of this approach is the whole state is controlled by one component, and the disadvantage that pacing the state affects all the entire chain of components. This very problem is called property drill. But in the example, we will consider a model. One each is the components stores its own state. This is not the best idea, since while expanding our application, it becomes more and more difficult to maintain such code. Each component in React application may store a state. In addition, each React component should have some logic by which the state update. And of course, components can do the rendering, display some UI elements. Now let's imagine that we are working with a large and non-trivial application in which some components are connected. On this one hand, we do not want to store in each component its own piece of state. But on the other hand, we don't want to get the property drill problem and pass our property through many layers of the application. What if abandon the local state storages in each component for our application, and instead of the agree that all application data will be stored centrally in one large store, and the state will be available for each component like this? Then we could remove all the local states storages and work with one big common state. Well, as you might see on diagram, our components became lighter because we took away part of the responsibilities for storing state from them. It won't be hard to imagine how it would be possible to implement such an architecture using, for example, the context in React. Seems like problem is solved, but it's really so. The main reason why they will never work is a complete loss control our state's changes. Each component can now read or write the global object whatever it wants. That doesn't mean we should throw the idea away, but let's try come up with some working solution. How we can make updating the global state a bit more controlled. What if we fix the problem is preventing the component from updating the global state? Our components can read from the global state, but will be strictly forbidden to write it, make any changes. Sound better? But we still need to update the state. If not the components will update our state, then who? how the business logic is going to be implemented. Let's say that in our application we will go a step forward, and after renovation of entire state from all the components to global state, we will do the same with logic and create some kind large global repository of logic. Let's draw a square in our diagram and say that it knows how to update the state for absolutely any event in the application. Since the square implement logic, it's actually just a function. That function knows what to do and how to update our global state. The user clicked on the delete item from our to-do list. Our function knows that you need to remove the item from the state array and count how many things are left in the list and how many of them are done. Status and so on. Let's call the function reducer. Well, now let's remove the little squares with logic from our components, because all our logic has been moved to reducer function. Perforce, let's show its diagram. The reducer updates the state. And the last question remains. How now to connect our components with the reducer function? Yes, just like before, we organize the interaction between components and different levels with the help of events. We will say that components cannot directly change the state, but components can create events that will pass to this reducer function. The function will know how to update the state for absolutely any event in our application. In fact, we have just taken apart the architecture of Redux, and to make this picture a little more correct, in the Redux terminology, the events are called actions. And there is another component that organizes the operation of the reducer function and controls the state updates. It's called store. To make the scheme over cleaner, imagine that you look a regular React application and combine all the local states of the components into one large state. Then you look all the logic that change the state, but it into separate functions that called reducer. In order to update the state, for example, in response to the fact that the user clicks on some button, the React component can create a special event, which in terms of editors is called action. This action is essentially an ordinary JavaScript object that describes what needs to be done, but reducer knows how to do it. Reducer updates state, and the state makes the React component render the new state on the UI. That's all. I don't know how to answer your question, but okay. I don't know, but I imagine how Redux worked in one more? Maybe. Yes. It's no. It's way lecture, like easier of for describe. No, please, please. No way.
Hello, my name is Anya, and I want to talk. Yes. Okay. And I want to talk about CSS grid layout. CSS grid layout introduces a two-dimensional grid system to CSS. Grids can be used to lay out major page areas or small user interface elements. A grid is an intersecting set of horizontal and vertical lines, one set defining columns and the other rows. We can create a grid container by declaring display grid or display inline grid on element. As soon as we do this, all direct children of that element become grid items. In this example, we have a containing div with a class of wrapper. And inside are 5 child elements. I make the wrapper a grid container. In web browser, you won't see any difference to how these items are displayed before turning them into a grid, as grid has created a single column grid for the items. If we want to start making this more grid-like, we need to add column tracks. We define rows and columns on our grid with grid template columns and grid template rows properties. These define grid tracks. A grid track is the space between any two lines on the grid. We can add tracks to our previous example by adding the grid template columns property and create a grid with 3 200 pixel wide column tracks. The child item will be laid out on this grid, one in each grid cell. Tracks can be defined using any length unit, but grid also introduce an additional length unit to help us to create flexible grid tracks. The new FR unit represents a fraction of the available space in the grid container. The next grid definition would create 3 equal width tracks that grow and shrink according to the available space. In the next example, we create a definition with 2 FR tracks and 2 1FR tracks. The available space is split into 4. 2 parts are given to the first track and 1 part each to the next 2 tracks. Large grids with many tracks can use the repeat notation to repeat all or a section of the track listing. For example, this grid definition with 3 columns, we can also written like this, with using repeat notation. Repeat notation takes the track listing and use it to create a repeating pattern of tracks. In this example, my grid will consist of 10 tracks, 1 FR track and then followed by 2 FR track, and this pattern will be repeated 5 times. When we created our example grid, we specifically defined our column tracks with the grid template column property, but the grid also created rows on its own. These rows are part of the implicit grid. The explicit grid consists of any rows and columns defined with grid template columns or grid template rows properties. If you place something outside of the defined grid, the grid created rows and columns in the implicit grid. In the implicit grid, tracks can be auto-sized by default, resulting in their size being based on the content that is inside them. You can also define the set size for tracks created in the implicit grid with the grid outer rows or grid outer columns properties. In the next example, we use grid outer rows to ensure the tracks created in the implicit grid are 200 pixels tall. When we define the grid, we define the grid tracks, not the lines. Grid then gives us numbered lines to use when position items. In 3-column and 2-row grid, we have 4 column lines and 3 row lines. Lines are numbered according to the written mode of the document. And also lines can be named. In the following example, we are placing the first 2 items to our 3-column track grid using the grid column start, grid column end, grid row start, and grid row end properties. Working from left to the right, the first item is placed against column line 1 and spans to column line 4. It begins at row line 1 and ends at row line 3, and spanning 2 row tracks. The second item starts on grid column line 1 and spans 1 track by default, so we don't need to specify the end line. It also spans 2 row tracks from row line 3 to row line 5. The other items will place themselves into empty space on the grid. And that's what we got. And I would like to talk about grid cells. A grid cell is the smallest unit on a grid, and conceptually it's like a table cell. Items can span 1 or more cells, both by row or by column, and this creates a grid area. Also, we can add gutters to our grid. Gutters or alleys between grid cells can be created using the column gap and row gap properties. In the example, I am creating a 10 pixel gap between columns and 15 pixel gap between rows. Gaps act for size and purpose like a regular grid. But you can place anything into a gap. A grid item can also become a grid container. In the next example, we have the 3-column grid with 2 positioned items, and the first item has some sub-items. If I set box 1 to display grid, I can give it a track definition, and it too will become a grid. The items then lay out on this new grid. In this case, the nested grid has no relation to the parent. That's all. Thank you for attention. Maybe I can use another technology and don't use grids. Sorry. I don't know about it. Thank you for question. I like to use Flexbox. I don't know, it's more understandable for me, maybe. And I choose this topic to learn more about grids, because I didn't use it. Something like tables or what else? Yes, I can't remind the name of the technology. Thank you.
Hi everyone, my name is Pavel and I want to tell about Pavel Okuň. Yeah. This. We use this in much the same way and as we use it in natural language. Let's take two sentences. Albert likes eating and Albert hates cooking. We use pronoun he to combine these sentences so they become Albert likes eating and he hates cooking. Just like how the pronoun he connects sentences, this acts as a shortcut to refer the same thing again. Or somebody says, this is very exciting, without any reason or context as a start of conversation. Most probably you will start to connect this with something around or the latest situation. In a browser we also can use this without context. Let's enter in the console log this, and what do we get? The window object. That's because in the global scope, this refers to the global object, and in a browser, the global object is a window object. Now let's put this inside of a function. What do we get? Also the window object. That's because in the the keyword this returns to global object. This happens because this is not inside of a declared object, so it defaults to the global object. But if we're using strict mode, this will be undefined. It actually may be useful because prevents us from creating global variables. The other function, the other way function can be invoked is method invocation. When this is used inside of a declared object, the value of this is set to the closest parent object the method is called on. Take a look at the code. I declare the object school with and use this inside the method as a method full. To better illustrate that this is a reference in the school object, we can to console log this to see what it returns. The console returns the school object because this has taken the value of school. The other situation when we have nested object. Let's see at the code. We've got the school object that contains the same first, second, and full keys, and nested in the current object with the same 3 keys. What's going to happen when we call our methods? So the value of this is the closest parent object. The method is called on, and when school full is invoked, this is bound to the school object. Meanwhile, when school current full is invoked, this is bound to the current object. The third way the function can be invoked is constructor invocation. When the new keyword is used, this is bound to the new object being created. Let's look at the example. You can think that this is bound to the global object, and you would be correct until we add in the keyword new. When we use new, the value of this is set to an empty object, in this case our planet. So when a constructor call is made, a new object is created and set at the function's this argument. The object is then implicitly returned from the function unless we have another object that is being returned explicitly, like in this example. Here, because an object was returned during construction, the new object that this was bound to simply gets discarded. And the last, arrows. Arrow functions work differently from regular functions in terms of context. This will always refer to the lexical scope. Take a look. In global code, this will be set to the window object. Hence, we get true. When we use arrow function, this retains the value of the enclosing lexical context. Notice the difference between the arrow and the regular function. With an arrow function, we are in a window context. Using a regular function, the value of this is the closest parent object. The method is called on. Inside a function, the value of this depends on how the function is called. Also we can set the value of this explicitly with call, apply, and bind. They are similar but have some differences. Call and apply are invoked immediately. Call takes any number of parameters, this and the additional arguments. Apply takes 2 parameters, this and the array of the additional arguments. Apply here we have the function birth and the object 19. We can use call and apply to call the function with our object. When we use birth call, the first parameter is what this should be bound to. The other parameters are passed into the function we are calling. So in birth, this A refers to 19th A, and this B refers to 19th, and we get 1995 returned. Birth apply is similar. First parameter is what this should be bound to. The second parameter is an array of arguments to be used in the function. And what about bind? The parameters in bind are identical to call, but bind is not invoked immediately. Instead, bind returns a function with the context of this bound already. Bind is useful when we don't know all of our arguments up front. The example should help with understanding. Now, what if we don't know the second argument yet? We can use bind. If we console log our variable, we can see what we are working with. We have also already passed in our first argument as the number 90. Later, when know the second argument, we can pass it in. The bind method permanently sets the context to the provided value. After using bind, this is immutable, even by invoking call, apply, or bind. And summing up the story, let's go over the points. The value of this is usually determined by a function's execution context. In the global scope, this refers to the global object. The value of this is the closest parent object the method is called on. When the new keyword is used, this is bound to the new object being created. Arrow functions don't bind this. Instead, this is bound lexically. And we can set the value of this explicitly with call, apply, and bind. And now you got this. Yeah, that's all. Yeah, I saw this, but I don't know why, because tabs. Yes. One, only one. Yeah, I use one. But in reveal, I think one. No? Yes? Yes. Yeah, I said that one. Yes. Because when we want to call the constructor, we write a function with we starts it with big letter. Yeah, I think that it will work, but developers don't do this. Kill. Okay, thank you.
I'm back. Check. Hello, my name is Pavel, and I would like to talk about laziness. Laziness, of course, in React. Everyone would like to relax or do what they love, and the work would do itself. But today, it is unfortunately impossible for us. However, it is possible to improve the performance of our application so that it runs faster. And React gives us such an opportunity. I suggest considering two ways to increase the performance of our application. The first way is simple. Just use Webpack. Most React apps will have their files bundled using tools like Webpack. Bundling is the process of following imported files and merging them into a single file, a bundle. This bundle can then be included on a web page to load an entire app at once. As your app grows, your bundle will grow too, especially if you are including large third-party libraries. You need to keep an eye on the code you are including in your bundle so that you don't accidentally make it so large that your app takes a long time to load. To avoid winding up with a large bundle, it's good to get ahead of the problem and start splitting your bundle. And Webpack can create multiple bundles that can be dynamically loaded at runtime. The best way to introduce code splitting into your app is through the dynamic import syntax. When Webpack comes across the syntax, it automatically starts code splitting your app. And React lazy function lets you render a dynamic import as a regular component. Let me show you another way of laziness. React components can be defined by using React.component or React.pureComponent. The difference between them is that React component doesn't implement should_component update function, but React pure component implements it with a shallow prop and state comparison. If your React component's render function renders the same result given the same props and state, you can use React pure component for a performance boost in some cases. React components can be use should component update function. This is a method by which you can control the render of component when its state changes. The default behavior is to re-render of every state change, and in the vast majority of cases you should rely on the default behavior. Should component update is invoked before rendering when new props and state are being received. Default value is true. This method is not called for the initial render or when force update function is used. So here is a subtree of components. For each one, SCU indicates what should component update returned, and DOM indicates whether the render React elements were equivalent. Finally, the cycle's color indicates whether the component had to be reconciled or not. Since should component update return false for the subtree rooted at C2, React did not attempt to render C2 and thus didn't even have to invoke should component update on C4 and C5. For C1 and C3, should component update returned true, so React had to go down to the leaves and check them. For C6, should component update returns true, and since the rendered elements weren't equivalent, React had to update the DOM. The last interesting case is C8. React had to render this component, but since the React elements in returned were equal to the previously rendered one, it didn't have to update the DOM. Note that React only had to do DOM mutations for C6, which was inevitable. For C8, it bailed out by comparing the render React elements, and for C2, subtree, and C7, it didn't even have to compare the elements as we bailed out on should component update, and render was not called. So we were able to improve application performance without re-rendering components that did not receive changes. But be careful, React components should component update function only shallowly compares the objects. If these contain complex data structure, it may produce false positives or fast negatives for deeper differences. Only extend pure component when you expect to have simple props and state, or use force update function when you know deep data structures have changed. Calling force update will cause render function to be called on the component, skipping should component update. This will trigger the normal lifecycle methods for child components, including the should component update method of each child. React will still only update the DOM if the markup changes. So actually, I can talk about this picture. This is life cycle of component, normal behavior, default behavior. For example, the first render is done and we are here. we want to change some props or state, or these props or state were changing for other reasons, and we go here and ask a question: should component update or not? When true, then we go here and actually render our component. This is default behavior. But if props or state weren't changed, we go back and still here, and React will re-render, will not render the component again. But if we are sure that some props or some state inside the component was changed, we can say to React, update our component with via using force update function. And then React skips should component update function and goes to render our component. So thank you. So in documentation was the answer. There is problems with laziness on the server side. For now isn't impossible. I had this language in university. BNTU, National Technical University. Pascal, I had in the school. I think everybody had. Okay, thank you.